I'm not the hero, Jim is the hero. We should establish this quite quickly. Like all journalists, I've known him for some years, and of course he knows us much better and reads our little minds quite acutely. But we've all taken him very seriously for the last 3 or 4 decades, in fact, as long as I've known the spelling of the name, in fact. I can now confess this because I was thunderstruck by a wonderful New Scientist article in the 70s. In which, illustrated, I think, with a Rousseau painting, in which Jim actually unfolded his proposition that you could regard the biosphere as a living organism. That is, it's not a living organism in the sense that it reproduces, but you could regard it as one. It's a metaphor, but it's a wonderful metaphor. However, he's not just famous for that. When you wash your hands after blowing your nose, you're actually recreating pioneering work by Jim when he was at the Common Cold Cure Research Unit. We'll get back to that at some point. When you worry about organochlorine pesticide spreading through the countryside, Jim measured it. He devised the instrument that can measure to accuracies of 1 in 10 million billion. That is, this stuff couldn't possibly harm you. He famously once said this in a Nature paper. Stuff couldn't possibly do any harm at all. It's just interesting how precisely you can measure these small quantities of pollutants. And one of these pollutants, of course, was CFCs, which, of course, created the hole in the ozone layer, so you can associate that panic with Jim as well. It's a long picture of doom and gloom, really, isn't it? And,
sure is.
In his latest book, let's come to the other point of this meeting. There are 2 books, one by Jim, The Vanishing Face of Gaia, and in it he rather sardonically says you wouldn't have bought it if it had been called The Vanishing Face of Earth System Science. So, and the other is a very interesting biography by John and Mary Gribben, who I think are in the audience. Oh yes, I'm so sorry, yes, he was hiding. In fact, he was hiding. And both the authors and their books will be available afterwards for signing. And if you think you can get away without being persuaded once more to buy a book, you've got another thing coming, because I've been instructed by the publishers to mention this at least once. In an early chapter in this book, Jim describes himself as an unwilling Cassandra. Cassandra was the daughter of the king of Troy, and she was twice cursed by the gods. Once that she could see the future with terrible clarity, and the other is that no one would ever believe her. And this, for some of your life, seems to have been much the story. Is that possible, Jim? Did you have, it's been an uphill struggle?
It has indeed, yes. Over Gaia, it certainly has. It was, when I first came up with it, it was a long time ago. It was 1965. And I can remember it as vividly as if it were yesterday. It was in one of the offices at the place called the Jet Propulsion Laboratory in Pasadena, California. It was one of NASA's institutions. And there were just 3 of us in the room. There's Carl Sagan, who probably lots of you remember as a famous astronomer, now sadly dead. There was a lady philosopher called Diane Hitchcock, who I was working with at the time, and me. And we were talking about this endless problem, how do you find life on Mars? And I'd been saying for quite a long time that the best way to do it would just be to measure the atmosphere of the planet. And at that time, NASA were going to send instruments to Mars to measure the composition of the atmosphere. NASA believed it. They weren't against it. And then in marches an astronomer and said, look at this. And he brought out sheets and sheets of data that had been gathered at a French observatory at Pic de Midi by a husband and wife team called Pierre and Jeanine Cohn. And this data showed quite clearly that both Mars and Venus had atmospheres that were almost entirely carbon dioxide with just traces of other gases present. And according to my theory, it meant they were completely lifeless. So there was no point in NASA sending anything there to find it, because they wouldn't. However, they didn't listen, because they still keep sending stuff there.
But I have to point out, they think they've discovered methane in measurable quantities on Mars. And would you count that as life, or can you gather it by some other geological process?
Well, I wouldn't yet, because the discovery of methane on Mars is a bit like the discovery of CFCs, as you so clearly said, on the Earth. The quantity is so small that you can't really draw conclusions about it.
When you just take people back to how we thought planets formed at the time of this, because what was it that made you leap to the conclusion that if there was no oxygen, there wouldn't be life?
I didn't really. The results that this chap brought in from the the observatory in France, what that set me thinking in my mind was, well, do we have a control planet with life on? Well, we do, obviously, our own planet. What's special about its atmosphere? Not so much that it contains oxygen, although the amount of it is pretty unusual, 21% compared to the other planets. What's special about it is that you've got oxygen in quantity mixed with methane in quantity. And those are two gases that react together. Every time you light your boiler, you know they do if you're burning natural gas. And if the composition had been different, the atmosphere would have been explosive or combustible, which would have been highly undesirable. But if you do your sums, we know that the rate at which methane reacts with oxygen in sunlight, and it means that there must be enormous sources of both of them down on the surface continuously. And much more remarkable than that, we know now from ice core evidence, we didn't know it then, but we suspected it, the amount has been more or less constant for millions of years. So here was something that was incredibly unusual. Chemistry told us that there was nothing that would allow those two gases to have appeared by accident, by ordinary chemistry. So something must be both making them and regulating the amount that was made. And that made me think of Gaia. And then Carl Sagan immediately said, because he was an astronomer, knew about these things, as John would know, that was I aware the sun had been warming up ever since it was born. And this was one of the great puzzles of astronomy. How on earth had the Earth kept its temperature constant over all of those billions of years, despite a warming sun? It's warmed up by about 30% since it formed. And it then came to me instantly, well, if the organisms can regulate gases in the atmosphere, then they can regulate the temperature, because as we know, you've only to put a little bit extra CO2 in the air, and everybody's getting scared about it.
That seems like a great leap, but you must have arrived at it in stages.
No, it all came out in that bang, bang, bang. But I've been thinking about it, obviously, for a long time beforehand.
That what, in one afternoon in an office in NASA?
Well, it would be about 10 minutes in an office in NASA.
Right. That's the stimulus you need, folks, just 10 minutes with NASA. But I think we should wind the clock back a bit and just get you from a relatively poor childhood in South London to this condition where you are actually a scientist important enough for NASA to import from Britain during the McCarthy era. No, actually just after the McCarthy era, but at a time when British scientists were not famous for their interest in space. I think that's fair to say.
I'm afraid that there was an astronomer royal, I've forgotten his name, Woolley, was it?
Yes, it was Richard
who
Woolley,
said
yes.
that the very idea of an artificial satellite was utter bunk, and it was only about a year before the Russians put Sputnik up.
It is one of the great gaffes by a senior scientist, but Arthur C. Clarke warns us that that's the more eminent the scientist, the more likely you are to make one, by the sound of it.
Oh, well, I'll do my best this afternoon.
Yes, throw a grenade into this audience now. You in fact were always interested in science. You were always interested in technology. You actually got yourself initially to college studying part-time.
Oh, yes. Well, it wasn't a case of I would have liked to have gone to university in the sort of way that kids do now.
Yeah.
Although I'm not so sure I'd want to go to a modern university. But my parents were much too poor, even if I got a modest scholarship, to afford to keep me there. So there's nothing for it but to get a job. And I got a job as a lab assistant to a firm of consultants in the Fulham Road. And they touched all branches of the photographic industry, from making gelatin to the synthesizing the color dyes that he used. They were really skillful people. And I think I learned more in the 2 years I was working for them than any university in the world could ever have taught me. It was hands-on, practical science. And one of the first things that was drummed into me, you've got to do your work properly. You've got to do your measurements as accurately as you can and state what are the limits of it if it's a little bit vague. Because people's lives depend on it, people's jobs depend on it, and most importantly, the firm's income depended on it. That, I think, is a training that students don't get. Yeah. They're told by their professors or the instructors, oh, it doesn't matter if you don't get the right result. As long as you understand the method, that's all that's required in the examination. And I think this is a terrible thing. And if you go back in history, you will see that most of our really good scientists worked on their own and had to learn the hard way how to do things. They weren't taught. And most of good science didn't come from universities in those days. It came from, people doing their own thing. Faraday, for example, was a good example. He went as a lab assistant to Davy, didn't he? That's how he had to learn it the hard way.
And then, as a Quaker, and as I was interested to note, a member of the Catholic Society too, at the same time in Manchester University, you ended up at the National Institute for Medical Research during the war.
Well, you see, my girlfriend was a Guardian reader.
Yeah.
That was, in fact, more than a Guardian reader. That was before your time, Tim. Her uncle was dramatic critic on the Guardian, so I got to know most of the people on the newspaper, and we got free seats at the Opera House.
I thought you twigged to journalism.
I could not join the Catholic Society, could I?
No, of course not. And but your wartime work was actually so important that, although you could have been drafted for, in fact, you were prepared to volunteer for service. Well,
I was brought up in Quaker thinking before the war, and everybody then was convinced that war was absolutely unutterably awful, and it was something that one should do one's damnedest to avoid. And after all, World War I was horrific in many ways. It was a slaughterhouse. And that's what I thought it was my duty to do, was to be a conscientious objector. And it was very unsettling and unnerving, because instead of it being an awful ordeal, being, having white feathers shoved at me in the street or people being rude, they were cheering me on. Yes. Even the tribunal judges were mild and understanding. And it made me realize what an incredibly civilized country we lived in those days. And, but as the war progressed, especially after 1940, when I knew that all the food we ate was brought in by merchant sailors who were suffering appalling threats from submarines and so on, I couldn't stick being a conscientious objector. You got to join in, and so I gave it up.
But they wouldn't let you.
No, they wouldn't let me. But that was because what I was in a back room, to put it.
I think people would like to hear the story of of your experiments, your experiments on yourself with flamethrowers.
Well, no, not literally that.
Almost.
Almost. No, one of the jobs we had was to protect anybody in the services or civilians against damage from flash or flame. Most people don't know the radiation from a big fire will burn you at quite a considerable distance, and much of the harm done by flamethrowers isn't direct contact with the flame. There's a big enough area of flame. If you're standing 20 yards away, you get badly burnt from the heat radiation. So we had to devise ways of stopping it. And amongst the things that were developed by the group were those flash helmets, which you probably see in wartime photographs.
Yeah.
Quite a simple helmet that fitted over the face, very light, and that was enough to stop the thing. We also discovered, which led on to Gaia mainly in an odd sort of way many years later, was that the best protection against flame is wool, even dry wool. It carbonizes immediately. The radiation hits it and forms a layer of carbon in bubbles, which is a beautiful insulator. And it suddenly dawned on me many years later, well, that's of course a natural evolution. Animals' fur, because forest fires have always occurred. This is a wonderful protection against fire. It doesn't ignite, it just forms an insulating layer. So, no. The personal side that you were interested in was my first quarrel with biologists, really. I hope there's no biologists in the room, but one thing I found about them is they're rather cruel people. They're taught biology at school, and they have to carve up living frogs and things like that as part of it. At least they used to in my time. And I found this utterly revolting and wouldn't do it. And when it came to doing experiments on animals rather than humans for the burning business, there's no question I wasn't going to shave the skin of rabbits and then burn it, because although they would be anaesthetized, they'd be pretty uncomfortable when they woke up. So I thought there's no answer to it but to burn myself. And I'm glad that my colleague Owen Lidwell felt exactly the same way, and we both did that. The odd thing about it was both of us found that after burning ourselves for roughly a week and using up about half one's arm in the process, quite suddenly the pain of burning vanished. And from then onwards, it was as if our brain had said, oh, well, if they're crazy enough to go on doing that, we'd better turn off. And I can still burn myself without feeling it, but I still suffer toothache.
Yes. Right. In my lumbering way, I had tried to elicit that anecdote just so we could lead deftly to Gaia, but Jim led us there and then back again. So at this point, you've been writing books with the word Gaia in the title for. I'm dreadfully sorry, I can't remember the date of the first one, but it's a very long time
79.
ago. 79. And you produced The Revenge of Gaia in, I think, 2006. And we now have, I'll hold it up again just so you know that and of course the companion John Gribben volume is with us. This time you say a final warning.
Well,
but I feel that...
I don't want to go into this too deeply because I went into it on the Today programme this morning.
Many of these people will have got up too early and travelled too far.
I don't want to embarrass Stuart Prophet, who's sitting there. The truth is, they weren't my words.
Yeah, right. No.
Because a final warning, in a way. I mean, dash it, I hope that's not my last book.
Yes,
I want to live to be 100.
Yeah. Right, but nevertheless, I think you ought to tell people very quickly why they should buy this book, and in what sense you're warning them, because anyone who reads this book, and most of you won't have read the book because it has yet to be published, I think, will discover that we could be in for an uncomfortable time, and we're in for an uncomfortable time because you have been reading the signs that are presented to you by Gaia.
Yes, it's a complex story, really, and I think most of one's thinking that's worth anything comes not from reason, but from intuition. Many of my scientist friends don't like that. They would rather... they're still back in the 19th and 20th centuries where you did everything rationally. And in fact, the word irrational implies loose or bad thinking. I'm afraid it isn't like that. All things that really matter are intuitive, and understanding the Earth system is one of those things that you cannot express formally in mathematical terms easily. The climate scientists tried to do it. There was a man called Lorentz many years ago, and discovered that if you try to model a system containing more than 2 differential equations. And you've got to have not 2, but hundreds or thousands if you're going to look at the Earth system. It goes chaotic as soon as you put any realistic things on it. So what they tend to do is they have to model it that way by putting hundreds and thousands of equations. So they either fudge the equations and do linearizing modifications so that they never go, the thing never goes chaotic, or they never run it beyond what they call equilibrium conditions. They never allow it to behave dynamically as a living thing does. Now, this is absolutely fatal as far as modeling goes, and it applies both to biology and to climate science, geophysiology. And this is why we're finding now that the great gathering of scientists that formed the IPCC, some of our best climate scientists in the world, with the very best of intentions and the most modern and expensive equipment, are failing to predict the climate that is with us today. The most glaring error is that the sea level is rising nearly twice as fast as they were predicting. And this is a serious matter if you live in London, to get an error that big. So to understand the Earth system, you can't avoid approaching the whole problem to a certain extent intuitively. And this is where I think Gaia came in, because most of the first part of it was intuitive rather than rational. I can't really explain that more. And I think it has some deeper significance in that one of my reasons for being somewhat pessimistic about the future of the present generation of humans around is that I think the problem is right beyond us. We do not have the intellectual capacity yet to solve the system of living properly with our planet.
Is this a question just of intelligence, or is it a question of wisdom?
Well, wisdom is what counts. Intelligence is more attached to reason, especially the tests of it.
Yes. I'm going to throw this open to questions in a minute or two, but I'd quite like to just get Jim, while I have his undivided attention, on two things. One is the hostility that you provoked among both geologists and biologists, which always surprised me, because it seemed obvious to those of us who came to this problem for the first time that you must be right. That if the atmosphere is regulated by life, then the Earth the biosphere is a self-regulating system. But people wouldn't buy that. And the second thing that I'd just like you to make clear for people is in what sense Gaia is self-regulating if it means disaster for us.
Okay,
yeah.
I'll try and answer those two. I think the reason for the hostility with biologists was I made a ghastly mistake. One always does in life. I talked to what I call middle management biologists, who always work by the book. And the book said that what I was saying was rubbish, and therefore it must be rubbish. And they had as their primary spokesman Richard Dawkins. Yes. Now, you can't get a much more formidable opponent than that. And he really rubbished everything I said in his book, what was it, The Extended Phenotype. Yeah. I sympathize with Richard because he's a damn good writer. I think we both of us would be glad to write as well as he does. Yep. And he's got a good logical mind. But it was just unfortunate that he didn't understand this, that rational thinking is not the way of answering the problem. And what he said roughly was, there is no way for any organism to regulate anything beyond its phenotype, that's to say its sort of outer carapace, so it could never possibly regulate the Earth. What he didn't understand was that the whole Earth system, made up of all the organisms, the atmosphere, the oceans, and the surface rocks, together as a cooperative system can regulate itself. And that was understandable. I didn't understand it myself, so at first I couldn't really reply to the biologists, only say, I know you're wrong, and that doesn't get you very far. And it wasn't until I made a very simple model called Daisy World that demonstrated quite clearly that you could get self-regulation by Darwinian natural selection without any problem at all. And it took a long time before that got swallowed.
You also had trouble with the geologists who felt that the Earth was an inviting habitat in which life could invest in.
But not in this country. That was mainly America.
Yeah.
I think American geologists tend to have a training that is rather macho and Germanic in attitude. The Herr Professor says this, so it must be right, kind of thing. And I was saying something that jarred with their teaching. They were much more broad-minded in this country, I found.
And my last question there was, if Gaia is a self-regulating system, how is it that we're all going to perish? What is going to go wrong from our point of view?
From Gaia's point of view, and I speak for Gaia much more than I do for people, I don't think she gives a damn for us. As far as the planetary system goes, it will always self-regulate so as to sustain habitability. And what we've done is to mess about with the atmosphere, and much more importantly, I think, mess about with the land surface in the way of farming, taking out natural ecosystems that were previously regulating the climate. We've done those two things, a double whammy. And so, naturally, as any living thing would do, when it finds it can't self-regulate and can't defend, it's moving to a place that it knows it can defend, and it's moving to a hot state that it's been in many times before, and it can self-regulate quite comfortably, and we'll have to make do. We won't be destroyed by any manner of means, but the amount of land that will be available for people will be to live on will be much less than it was.